Okay, so today we're going to just do this one example, which is on page 27 of your notes booklets. And I hope you have access to your notes booklets. Page 27. You might let me know if you don't have access to your notes booklets at the moment. You can, of course, just take this down into a separate copy in any case. And this is the last example that we're going to do on tripletaneous equations. So that's simultaneous equations with three unknowns. But rather than us just getting a straightforward question to do, we have a word problem. So you'll have done things like this for junior cert, but of course you only had to create two equations. Now we have to do the same thing, but we're creating three equations. So if we read the question, we can see it starts by telling us that a school has 82 students in classes P, Q, and R. And that's the first piece of information that they've given us. At a guess, we know that we're going to be asked to find the values of P, Q, and R. You could probably guess that from the beginning. There are X students in class P. I suppose we're going to use X instead of P. Y students in class Q, and Z students in class R. So just to make that nice and clear for ourselves, we might make a quick little note to the side that X are the students in P, Y are the students in Q, and Z are the students in R. Okay. So the next piece of information they give us is that 1/6 of class P, 1/3 of class Q, and 1/2 of class R study maths. So we're going to have fractions involved in this as well. 1/10 of P, 3/8 of Q, and 1/4 of R study chemistry. And they also tell us that 27 students study maths and 19 study chemistry, and they want us to find the number of students in each class. So what are they actually asking us to do? They want us to find the values of X, Y, and Z. Now hopefully you can see there that they've given us three pieces of information. These fractions here that study maths, and that maths adds up to 27, is our second piece of information. These fractions of the class here that study chemistry, and that chemistry adds up to 19, is our third piece of information. And let's write down the equations from that information. So I'm hoping, apologies now for the Zoom, it's not working the way I thought. I'm hoping that you can see that the total 82 students in the three classes must be the sum of X, Y, and Z. I hope you can see that, because P, Q, and R will all add up to 82. So X plus Y plus Z will give us a total of 82. That's coming from the first piece of information there. The second piece of information is using the fact that there are 27 students studying maths, and the different fractions of each of those will add up to 27. So 27 study maths. And from the information they've given us, we should see that 1/6 of X, 1/6 of class P, plus 1/3 of Y, 1/3 of class Q, plus 1/2 of Z will add up to 27. Now there's a couple of things here. I want to remind you that we don't have to write our fractions next to the letters like that. If you want to keep them next to them, you can. But a sixth of x is the same as x over 6. A third of y is the same as y over 3. And a half of z is the same as z over 2. So I would rewrite this equation as x over 6 plus y over 3 plus z over 2 equal to 27. And I would get rid of the fraction straight away. Okay? And how do we get rid of the fraction? Well, we multiply across by a common denominator. And in this case, the common denominator is 6, because 6 goes into 6, 6 goes into 3, or 3 goes into 6, and 2 goes into 6. And of course I will have to multiply the other side of the equals by 6 as well. So then what happens? The 6 on the top there and the 6 on the bottom there divide in. 3 into 6 goes twice. 2 into 6 goes 3 times. And rewriting my equation, I get x plus 2y plus 3z equals 6 by 27, 162. 162. And that is my second equation. So that's my equation 2. I already have my equation 1. Now, the third piece of information came from the chemistry class. And we were told that there are 19 students studying chemistry. Okay, so the fractions that we have, 1/10 of p, 1/10 of x, and I'm going to go ahead and just put it over the denominator now straight away, rather than doing the extra step that I did here. So x over 10 plus 3y over 8 plus z over 4 is equal to 19. There's 19 studying chemistry. And again, I'm going to get rid of the fractions by multiplying across by a common denominator again. And in this case, my common denominator is going to be, unfortunately, 40. It's the smallest number that 10 and 8 and 4 will all go into. So I'm going to multiply each term there by 40. There's nothing smaller that I can do. I'll multiply here by 40, here by 40, here by 40, and yes, even the 19 has to get multiplied by 40. So 10 into 40 goes 4 times, 8 into 40 goes 5 times, 4 into 40 goes 10 times, and when I write this out, I've got 4x plus 5 by 3, 15y, plus 10z equal to 40 by 19, giving me 760. So it's a big number, but we have calculators, so it should be fine. And that is my third equation. Now, all that's left to do is to solve these in the usual way. So if we look at the first two equations, we can see that 2 of them have a coefficient of 1 in front of the x. So it's probably easiest to cancel x first. I'm going to cancel x. And what I'll do is I'll do equation 2 and take away equation 1. Now you might prefer to write equation 1 down first, but if you notice, if I do this one, take away this one, I won't have a minus number at the start. It doesn't matter. As you know, you get the same answer whichever way around you do it. So equation 2, take away equation 1. Take away just means that I change the sign. Equation 2 is x plus 2y plus 3z equals 162 minus equation 1. So minus x minus y minus z equals minus 82. I line those up and subtract my like terms. The x's cancel. 2y take y is y. 3z take z is plus 2z. 162 minus 82 is 80. So there I have my equation 4. Equation 4. And now I'm just going to move the camera slightly to come up here. Okay, I need to cancel x in another pair of equations, so I always cancel the same letter twice to get my two new equations. This time I'm going to cancel x by putting equation 1, for a second, equation 1 and equation 3 together. So I've done 1 and 2 together. I can either do 2 and 3 or 1 and 3, and 1 and 3 is probably the most straightforward. Okay, so cancel x by doing equation 3, take away 4 times equation 1. And the reason I have to do that is because in equation 3, I have a coefficient of 4 in front of x. 4x plus 15y plus 10z equals 760. And then take away 4 times equation 1. So I have minus 4x minus 4y minus 4z equals 82 by minus 4 minus 328. And again, subtract my like terms to get equation 5. The x's cancel, which was the plan. 15 take 4 is 9. 10 take 4 is 6. And 760 take 328 is 432. So 3 should divide into all of those and simplify my life when I put equation 4 and 5 together. And because I've spotted that I can divide across by 3, I will. If you don't spot it, it's fine, it will still work out. You just might have to work with a little bit bigger numbers in the meantime. So 3y plus 2z equals 144. And that is my equation 5. Now, looking at equation 4 and equation 5, the obvious thing to do is to cancel z, because they both have the same coefficient, so all I need to do is change the signs. I cancel z, and I'll do that by equation 5, take away equation 4, just because it means I won't have a negative answer when I'm working with it. Equation 5 is 3y plus 2z equals 144. Equation 4, which I'm subtracting, minus y minus 2z equals minus 80. And the z's cancel, which was the plan. 2y equals 144 minus 80, and that gives me 64. So y is equal to 32. And then it's very straightforward from there. I sub into, it doesn't really matter which one I sub into, I'll sub into 4. And I get 32 plus 2z is equal to 80. 2z is 80 minus 32. 48, and Z is 48 divided by 2, 24. And the easiest one then to sub into for the last one, sub into equation 1. What am I subbing in here? I subbed in y equals 32. And here I'm subbing in y equals 32 and z equals 24 because I know those two values. So instead of x plus y, I have x plus 32 plus z plus 24 equals 82. And I can work out the value of x from there. X plus 56 equals 82. X is 82 minus 56, which is 26. Okay, have we answered the question there? Well, we found the values of x, y, and z, and I do believe that you would get full marks for this, but let's make it perfectly explicit. So the answer that we'll write down will be the values for class P, class Q, and class R. And class P has 26 students. Class Q is Y, has 32 students. And class R is Z, 24 students. And of course, you can verify that those numbers make sense in the context of the question that we were given, if you have time, but you won't always have time. Now, we're going to stop there for today. I would like you to try a couple of questions with word problems. One is with a simultaneous equation with two unknowns, and one is a simultaneous equation with three unknowns. So those are in our book 4 on page 43, question 10, and page 44, question 23. What I'm going to do is the usual thing with Google Classroom. So I'll upload a screenshot into Google Classroom, and I'll upload this video there as well. And please let me know your questions and your suggestions. Best of luck with it all. Okay, thank you.